So we want us to look at this particular question under coordinate geometry in addition mathematics. The question reads as follows. In the diagram, BPCR is a rhombus. The line PR and BC bisected Q. The length of the line PR equals to 2BC, and PR, the length of the line PR equals to 8 root 2. This is the rhombus you're seeing here. Another question asks, calculate number 1, the value of T and the coordinates of R. Number B, calculate the equation of PR. And number C, calculate the area of the rhombus. So let's see how we answer the first question, the value of T and the coordinates of R. Let's get started. So let's get started and see how we answer. The value of T. How do we find the value of T? Well, we're going to use this particular information that has been given for us. For you to find the value of this T, it's important to know the length of the line BC. Take note. For us to know the value of T, which is the Y value in this coordinate, it's important that we know the length of the entire line BC. But you're given here that the length of PR is 2BC, and the length PR is actually 8 root 2. So you can make BC the subject of the formula, where we now know what PR is. PR is 8 root 2. So where we have the PR, we'll write 8. Check note. We're going to write, where the PR, we'll write 8 root 2 equals to 2BC. Then we make BC the subject by dividing by 2. We cancel the 2's. We have BC being equals to 2 into 2 is 1, 2 into 8, that's 4. So we have 4 root 2. This is BC length. This is the length of line BC. Now, this being the case, we now apply what we call the distance formula. Yes, we're going to apply the distance formula, the distance between point B and point C. So we're going to use what we call the distance formula. So the distance between point B and point C. As you may be aware, this will equals to the square root of x2 minus x1 in the parenthesis raised to the second power plus y2 minus y1 in the parenthesis raised to the second power. Now we're going to establish and figure out what B is. So the coordinate of B is 2, 0, and the coordinate of C are 6, t. Now we're going to label B as x1, y1, and C as x2, y2. Then you plug in these into the formula. So x2, that is 6 minus x1, that is 2 raised to the second power plus y2, we know that is t minus y1, that's 0 raised to the second power. Then everything under the square root here. Then we're going to simplify this and have something. We're going to say, what you have inside there, that's 6 minus 2, that's 4. So that is 4 raised to the second power plus t minus 0 is t. So to be t to the second power. Then everything will be in the parentheses. Then we put the square root, and this is 16 plus t raised to the second power. So this is basically what we have inside the square root. But we know here to say the length BC. You can say, but we know here to say, but length BC equals to, we know it is 4 root 2. Thus, 4 root 2 equals to the square root of 16 plus t to the second power. Remember, the idea here is to find the value of t. How do we do it? Well, we're going to remove the square root here by squaring both sides of this particular equation. So I'm going to put this in the parentheses and raise everything to the second power. We put everything in the parentheses and raise to the second power. Once this is done, you're going to appreciate that we have this 4 is actually 4 to the second power, and the square root of 2 is in the parentheses to the second power. Then we are going to simplify this and say the root and the power 2 will cancel out. So we're going to have 16 plus t squared. Then you simplify further. 4 squared is 16 times the root and the power 2 fall off, so we have just a 2 here, and this will equal to 16 plus t to the second power. Are we seeing? Then we know 16 by 2, that's 32, and this will equal to 16 plus t to the second power. Are we seeing? This is what you do, right? And this is what we have. So we now want to make t the subject of the formula. If we do so, we're going to have 32 minus 16 equals to t to the second power. 32 minus 16 is 16 equals to t to the second power. So we know here that we can square it and have something like t squared equals to 16. So in the square root both sides, we're going to have t equals to the square root of 16, which we know t equals to 4. And thus I find the value of t as 4. Therefore, the value of t equals to 4. Thus I find the value of t. Let's move on to part B. Now we are asked to find the equation of line PR. So how do you go about it? Well, it's simple. So the concept that we're going to use here is the concept of we know to say this particular line, we can easily compute or calculate the gradient of this particular line here. It's very much possible to calculate the gradient of this particular line. And we know to say the gradient of this particular line times the gradient of this particular line, PR, will give us -1, because these two lines are perpendicular to each other. So the gradient of the perpendicular lines equals to -1. This much we know. So this simply means if we know the gradient of this particular line, we just are going to reciprocate its gradient and negate it. And that will be the gradient of the line PR. That's basically the concept we're going to apply here. So simple, right? Very simple. So now let's see and find the equation of that line PR. Let's see and get started. So finding the equation of line PR, we have this particular equation that we use, y equals to mx plus c, where c is the y-intercept, and m is basically the gradient of that line under review. So then how do you go about it? Remember, we want to find the equation of this line PR. Now, we know it's not easy to find the gradient of this line PR, because line PR has got only one defined point, which is 0,6. So the concept we're going to use is by first of all finding the gradient of this line, which is well defined. Well defined in the sense that C and B have got coordinates. This is 2,0 and the C is 6,4, because the T we got to find what T actually is. Okay, so let's first find the gradient of line BC. Yes, the slope of BC. So this is the slope formula or the gradient formula for line BC. Take note, and we know to say BC is this particular line which you're seeing there, 2,0 and C it is 6,4. So let's try to plug in these 2 points into the formula. We see here that y2 is 0 and y1 is 4, x2 is 2, x1 is 6. When you simplify this, we're going to have minus 4 over 2 take away 6, that's minus 4, which will give us positive 1. So the gradient of this line BC is actually positive 1. Now we know from the formula to say the gradient of any 2 perpendicular lines, it will be gradient 1 and gradient 2. The product of the gradients of any 2 straight lines, or perpendicular lines rather, will equals to minus 1. This is the formula. But now we know the gradient of M1 as 1. So for you to get the gradient of M2, you simply negate it and it will be minus 1. So simply saying M1 will be our 1, our first gradient here. So we put 1 times M2 will give you minus 1. 1 times M2 is simply M2 equals to minus 1. So the gradient of line PR is basically the opposite of this, the negative reciprocal of the gradient of BC. So in this case, the gradient of PR, take note, the gradient, or we can say the slope of PR will equals to minus 1. Okay, remember the formula is just right here. So we now know what M is, but we do not know what C is. However, if you go back here, we see that for you to get the C is basically the y-intercept. Yes, the y value at which PR, the line PR cuts the y-axis at that particular point. The y value is actually the y-intercept, which is the C you are seeing here. So in this case, the C is basically the 6, because this point has got 0,6, and this is x value and this is y value. So this 6 here is actually the C, which is the y-intercept. So C is now defined. We know what C is. With that in mind, we'll say therefore the equation will look like y equals to, take note, mx plus c, where we know to say y equals to m is minus 1 times x is minus x, the c is plus 6, and this becomes the equation of line PR. So this is the equation of line PR, and this is the answer. Thank you for watching.